Saturn looks peaceful from Earth, almost like a golden dream wrapped in beautiful rings. But the closer we look, the more disturbing it becomes. No solid ground, violent winds, strange magnetic forces, and moons that may be hiding oceans beneath the ice. Tonight, we'll explore why Saturn may be the scariest planet of all. Please help me with one subscribe so I can reach my goal of 1,000 subscribers. Thank you sincerely. Comment where you're watching from. Imagine looking through a telescope late at night, when the house is quiet, the lights are low, and the world outside your window feels almost motionless. And there, floating in the eyepiece like something too perfect to belong to nature, is Saturn. A pale golden globe wrapped in rings so thin and luminous that they seem less like matter than like a thought. A silent circle drawn around a distant world by some patient hand in the dark. At first, nothing about it feels frightening. Mars looks wounded and red. Jupiter looks enormous and storm-torn. Venus hides behind clouds hot enough to melt metal. But Saturn appears calm, elegant, almost gentle. And that is exactly where the uneasiness begins. Because the first disturbing truth about Saturn is that its beauty is not a sign of safety, order, or welcome. It is a surface impression created by distance, geometry, reflected sunlight, and the limitations of human vision. From Earth, we see Saturn as a composed object, a clean shape, a planet with a ring, something a child could draw in a notebook. But that simple image is a kind of illusion produced by scale. The rings look like a smooth halo only because they are unimaginably far away. In reality, they are made of countless pieces of ice, dust, and rocky debris moving around Saturn under gravity, collision, resonance, and orbital speed. The globe looks soft and painted only because the upper clouds blur together into bands of ammonia haze and high-altitude aerosols. The planet seems still only because it is nearly 900 million miles from the Sun on average, so far away that light itself takes more than an hour to cross the gulf and return Saturn's faint glow to our eyes. This is why Saturn becomes frightening the moment you stop seeing it as an icon and begin seeing it as a physical place. It is not a jewel. It is not a symbol. It is a real object, wider than 9 Earths side by side, turning in the cold outer solar system, carrying a mass roughly 95 times greater than Earth's. And yet it has no solid surface that would make sense to a human body. That single fact quietly changes everything. On Earth, the word planet gives us comfort because it suggests ground, horizon, weight beneath our feet, a sky above us, a place where direction has meaning. But Saturn removes that comfort. What looks like the visible edge of the planet is only the top of an atmosphere, a temporary level where gases become opaque enough to reflect sunlight back into space. Below that apparent face, there is no clean border where sky ends and land begins. There is only a deepening descent through hydrogen and helium, through clouds stacked at different pressures, through regions where gas becomes denser, warmer, darker, and more compressed, until ordinary categories begin to fail. The human mind likes surfaces because surfaces are endings. Saturn is terrifying because it does not offer one. Its first threat is not violence, but ambiguity, the refusal to become a place you can stand. This is where the mathematics of beauty turns into the mathematics of danger. A sphere is one of the simplest shapes in physics because gravity pulls mass inward from every direction, smoothing large bodies into rounded forms, and Saturn's rounded shape from afar gives it a serene completeness. Yet Saturn is not truly a perfect sphere. It rotates rapidly, taking only about 10.5 hours to complete a day, and because it is made mostly of fluid material rather than rigid rock, that spin pushes its equator outward and flattens its poles. The result is an oblate world, visibly wider around the middle, shaped by the balance between inward gravity and outward centrifugal effects. Even the planet's elegance is therefore a record of tension. Gravity trying to gather everything into symmetry, rotation trying to spread it outward, fluid layers responding with a shape that looks peaceful only because the forces have reached a long, cold compromise. The rings deepen that deception. Their flatness is not decorative, it is mechanical. Particles orbiting Saturn settle into a thin disk because collisions gradually remove vertical motion, leaving material moving mostly in the same plane around the planet's equator. What our eyes interpret as a perfect celestial ornament is actually the outcome of orbital energy being sorted, damped, and confined over time. The ring plane is a memory of motion disciplined by gravity. And because the rings are so broad and so thin, their beauty is almost unsettling in a geometric sense. They extend hundreds of thousands of miles across, yet in many regions they may be only tens of feet thick, a vast shining blade of ice around a world that could swallow Earth more than 700 times by volume. This contrast between width and thinness feels wrong to human intuition, like a cathedral roof made of frost or a continent reduced to a sheet of light. The more precisely you understand Saturn, the less comforting its image becomes. History itself follows this same pattern. When Galileo first turned his telescope towards Saturn in 1610, he did not see clean rings as we know them today. His instrument was too limited, and he described Saturn as having strange companions, or handles, as though the planet had ears. Decades later, Christian Huygens proposed that Saturn was surrounded by a thin, flat ring not touching the planet, an idea that required not only better observation, but a new willingness to accept that nature could arrange matter in forms no ancient cosmology had expected. Later, Giovanni Domenico Cassini identified gaps in the rings, revealing that the halo was not one solid structure, but a system with divisions and complexity. Each improvement in observation removed a little of the mystery while adding a deeper one. Saturn became less like a myth and more like a machine, but the machine was stranger than the myth. This is one of the quietest fears in science. Knowledge does not always make the universe feel smaller or safer. Sometimes it sharpens the outline of the abyss. The same golden disk that seemed peaceful through a backyard telescope becomes, under spacecraft measurements and modern physics, a layered, fluid giant with a complex gravitational field, powerful winds, interior heat, ring-moon interactions, and no human-scale environment anywhere near its visible face. Its color, too, participates in the illusion. Saturn's atmosphere is paler and less dramatic than Jupiter's, partly because of colder temperatures, high-altitude haze, and weaker contrast between its cloud bands, so it appears subdued, almost sleepy, like an old lantern in fog. But subdued does not mean mild. Those gentle bands are moving airstreams wrapped around an entire planet, shaped by rotation, pressure gradients, internal heat leaking outward, and seasonal changes across a world whose year lasts nearly 30 Earth years. Because Saturn is far from the Sun, it receives much less sunlight than Earth. Yet it still radiates more energy than it absorbs, suggesting that heat from its interior continues to influence its weather. Some of that energy may be connected to slow gravitational settling and helium separation deep inside, sometimes described as helium rain, though the details of Saturn's interior remain an active area of research rather than a completely settled picture. Here again, the beauty becomes disturbing because it is not passive. Saturn is not merely illuminated. It is internally alive in a physical sense, slowly releasing ancient heat while its upper atmosphere drifts in muted colors above depths no probe has ever fully crossed. The first glance cannot tell you this. The first glance only gives you the ringed silhouette, and the brain, hungry for pattern and calm, turns it into a postcard. But if you imagine approaching Saturn, the postcard dissolves. The rings would no longer be a smooth line. They would become a region of orbiting particles, bright arcs and shadows, gaps carved by resonances, embedded moonlets disturbing nearby material, icy fragments reflecting weak sunlight against the black. The planet would grow until it filled half the sky, and its calm bands would become enormous atmospheric roads curving beyond sight. There would be no blue sky in the human sense, no breathable air, no stable ground, no familiar sunrise, only a gigantic gradient of pressure and chemistry. The scale would make ordinary fear feel too loud, because Saturn does not need sudden movement to threaten anything that enters it. Its danger is built into its size, its depth, its composition, and its distance from everything we call home. A rocky planet can be hostile but understandable. You can imagine its cliffs, plains, craters, heat, dust, or ice. Saturn is hostile in a more abstract and perhaps more unsettling way because it denies the imagination a foothold. Even falling into it is hard to picture correctly. You would not strike a surface like a stone hitting desert ground. You would pass into thicker and thicker atmosphere, slowed, heated, crushed, and lost as the surrounding gas became denser than any air you have known. At some depth, pressure would become the story. At deeper levels, chemistry and phase would become the story. Farther still, if one could speak of farther inside a world with no floor, hydrogen would behave less like the gas in a balloon and more like an exotic planetary material shaped by immense compression. The horror is not that Saturn is chaotic beyond reason. It is that it obeys reason perfectly, and that reason has no concern for biology. In a way, Saturn is a lesson in the difference between beauty and kindness. Human beings often confuse symmetry with peace, brightness with safety, and silence with gentleness. But the universe does not make that promise. A snowfield can hide a crevasse. A calm sea can be deeper than a mountain is tall. A ringed planet can look like a sleeping angel and still be a world where no breath, no step, no shelter, and no return are possible. So when we ask why Saturn is the scariest planet, the first answer is not found in a monster storm or a violent explosion, but in that first quiet look, the moment we realize that the most beautiful planet in the solar system is beautiful from precisely the distance that protects us from understanding it too closely. Saturn is frightening because it invites the eye while rejecting the body. It gives us a perfect image and then removes every human meaning from that image. It lets us see a planet without offering a place. And as it turns slowly in the dim amber light of the outer solar system, wrapped in rings made of shattered ice, it seems to whisper one of the oldest truths astronomy has ever given us. Not everything that is magnificent is meant to be approached, and not everything that is calm is safe. If you tried to land on Saturn, the first terrifying discovery would not be fire or lightning or some violent wall rising to meet you from below, but the absence of the very thing your mind is searching for, a place to arrive. Every journey on Earth is secretly built around the promise of a surface. A plane descends toward a runway. A ship approaches a shore. A falling stone meets the ground. And even in our imagination of alien planets, we usually picture a dusty plain, a cracked desert, a frozen cliff, something solid enough to receive the weight of a body and say, "Here, this is where the sky ends." Saturn does not offer that mercy. Saturn is a planet, but not in the comforting terrestrial sense. It is a vast fluid world, mostly hydrogen and helium, wrapped in clouds that look from afar like a golden skin. Yet that skin is only an optical boundary, the altitude where the gases become thick and reflective enough for sunlight to paint them into a visible disk. If a spacecraft began to descend through those upper hazes, it would not break through a ceiling and reveal land below. It would enter a gradient, a long and worsening transformation of air into something denser, darker, hotter, and more crushing, where each mile downward is not a step closer to ground, but a step farther away from every familiar category of place. On Earth, sea level is a physical and cultural reference point, a line we can measure from, breathe near, build upon, and return to. On Saturn, scientists sometimes use a pressure level, such as 1 bar, roughly comparable to Earth's atmospheric pressure at sea level, as a kind of mathematical stand-in for a surface. But that is only a convenience of measurement, not a floor. It is like calling a depth in the ocean a coastline, simply because your instruments need a number. Beneath that chosen level, Saturn continues. The pressure rises because the weight of the atmosphere above increases, and the simple equation of hydrostatic balance, where pressure changes with depth according to density, gravity, and vertical distance, becomes less like a classroom formula and more like the quiet law of an abyss. At first, the descent might seem almost graceful. The pull of gravity near Saturn's cloud tops is not wildly different from Earth's, partly because, although Saturn is much more massive, it is also much larger, spreading that gravity across an enormous radius. This is one of the strange ways Saturn deceives intuition. It is huge enough to hold more than 700 Earths in volume, massive enough to dominate a system of rings and moons, and yet its cloud-top gravity would not immediately feel like standing on some crushing super-Earth. The danger is not simply the initial pull. The danger is what waits below, because in a gas giant, There is no cliff edge where the atmosphere stops being weather and starts being planet. The atmosphere is the planet, at least for a long time, and it thickens around you with the patient certainty of a deepening sea. A human body, a probe, a ship, anything made with our ordinary engineering assumptions depends on pressure differences remaining within survivable limits. Saturn's descent would remove those limits one by one. The outer clouds are believed to include ammonia ice high above, then deeper layers involving ammonium hydrosulfide and water clouds at greater pressures, not arranged like clean painted stripes, but as moving, turbulent, chemically active regions influenced by temperature, condensation, convection, and the rapid rotation of the planet. Each cloud layer is not a surface, but a weather system stretched around a world. Each layer tells you that matter is changing state, not that a landing site is near. This is what makes Saturn's lack of ground so disturbing. It turns the idea of arrival into a trap. The lower you go, the more Saturn becomes itself. The hydrogen and helium surrounding you grow denser as the pressure climbs, and the gas begins behaving less like the clear air we know and more like a compressed fluid. In everyday life, the difference between gas and liquid feels obvious because Earth lets us see water in a glass and air above it. But deep inside a giant planet, pressure and temperature can erase such familiar divisions. Matter follows the conditions imposed upon it. The old human labels still help us speak, but they no longer fully protect our imagination. At sufficient depth, hydrogen may become a fluid, and deeper still, under immense compression, planetary models suggest regions where hydrogen enters a metallic state, meaning electrons can move in ways that allow electrical conductivity, a key part of how giant planets can generate magnetic fields. The exact structure of Saturn's interior remains a scientific problem shaped by gravitational measurements, magnetic data, ring seismology, and equations of state for hydrogen and helium under extreme conditions, rather than by direct sampling all the way down. That uncertainty matters because Saturn is not a solved diagram in a textbook. It is a real world whose interior must be inferred from the faint ways it pulls on moons, twists spacecraft trajectories, vibrates through its rings, and radiates heat into space. In older planetary models, one might imagine a clear layered drawing: clouds, liquid hydrogen, metallic hydrogen, core. Modern understanding is more subtle. The boundaries may be gradual, the core may be diluted or extended rather than a neat, solid ball, and the distribution of heavy elements could be mixed through regions that are neither simple rock nor simple gas. This is where the fear becomes more intellectual and more profound. Saturn does not merely hide a surface, it may hide the failure of the surface concept altogether. Even the core, if one exists in the way models suggest, is not a floor waiting for a spacecraft to touch down. It would be buried beneath such crushing pressure and extreme temperature that the word landing becomes meaningless long before anything could reach it. A probe would not survive as a probe. A vehicle would not remain a vehicle. The surrounding material would become an environment so dense and forceful that structure, electronics, heat shielding, and communication would all be overwhelmed. The journey would end not with a dramatic impact, but with dissolution into conditions that turn engineering into debris and debris into chemistry. There is a quiet horror in that, because most catastrophic images have a moment of collision, a final event that the mind can hold. But Saturn replaces the event with a process. You are not stopped by a wall. You are gradually denied existence as a coherent object. This is also why comparing Saturn to a planet like Mars or Venus clarifies its particular fear. Mars is deadly, but it has landscapes. Venus is hellish, but it has a surface, mountains, plains, and a place where a lander can sit for a short time before heat and pressure destroy it. Saturn is more alien because it does not merely make the ground hostile. It removes ground from the story. If Venus is a furnace room with a locked door, Saturn is an endless atmosphere, becoming an ocean, becoming an interior state of matter that no human sense was designed to picture. The eye sees a disk. Physics sees a pressure field. The child sees a planet with rings. The astrophysicist sees a rotating, self-gravitating fluid body in hydrostatic equilibrium, flattened by spin, warmed from within, layered by chemistry, and governed by thermodynamics at scales where intuition becomes delicate. That phrase, hydrostatic equilibrium, sounds calm enough to belong in a quiet lecture hall, yet it describes one of the most merciless balances in nature. Every layer of Saturn supports the weight of the layers above it, not by kindness or strength, but because pressure rises until it can resist gravity's inward demand. This balance is why the planet does not collapse into itself, and also why entering it means entering a staircase of invisible force. There is no stable porch on that staircase, no balcony, no ledge with a view. There are only pressure levels, temperatures, densities, and compositions, each more severe than the last. And Saturn's rotation complicates even this descent, because a rapidly spinning fluid planet is not the same in all directions. Its equatorial bulge, banded winds, and internal mass distribution shape the gravity field in ways spacecraft can detect, while the atmosphere itself moves in jets that wrap around the globe. A descent near the equator would not be physically identical to one near higher latitudes. Direction would become less human and more mathematical, defined by reference frames, angular velocity, pressure coordinates, and the planet's immense rotating body. Even altitude becomes a strange idea when the 0 point is chosen by convention. Above Earth, altitude means height above a known surface. Above Saturn, altitude is tied to pressure levels and models because the world refuses to give you a natural foundation. This refusal is why Saturn is so frightening at the deepest psychological level. It is not just dangerous, it is conceptually unstable for a creature evolved on rock. Our bones, our balance, our architecture, our languages, even our stories assume that down eventually ends. Saturn says down continues until the words break. It lets you fall from sunlight into haze, from haze into storm, from storm into pressure, from pressure into fluid depths, and from there into interior physics that can only be approached through instruments, equations, and careful uncertainty. And all of this is hidden beneath the calm golden face we admire through telescopes on quiet nights. That is the disturbing part. Saturn does not look like an abyss because the abyss is wrapped into a sphere. It does not look like a bottomless world because distance turns its clouds into a surface and its rings into a halo. But if we follow the science inward, slowly and honestly, the familiar image disappears, and what remains is a planet that cannot be landed on because landing requires a promise Saturn never made. It is a world where arrival becomes descent, descent becomes compression, and compression becomes the final language of matter. So the fear of Saturn is not the fear of falling onto something, but the fear of falling into something so vast, so beautiful, and so indifferent that it never gives you the dignity of an impact. It simply takes away the idea of ground, softly, layer by layer, until the last human assumption has nowhere left to stand. To understand why Saturn's atmosphere feels less like air and more like an abyss, it helps to forget, for a moment, the gentle way the planet appears through a telescope, because that pale golden surface is not a surface at all, but the visible top of a vast planetary ocean made mostly of hydrogen and helium, an ocean without waves of water, without a beach, without a seafloor, and without a clear moment when the sky becomes the world beneath it. On Earth, the atmosphere is thin compared with the size of the planet, a delicate film clinging to rock and water. And even when we fly high above the clouds, we still know the mountains, deserts, oceans, and cities are waiting below like a final answer. Saturn gives no such answer. Its atmosphere is not a shallow covering placed over a solid globe. It is the beginning of the planet itself, a deep, continuous medium where pressure, temperature, density, chemistry, and light all change gradually with depth, until the language of ordinary weather starts to become the language of planetary interiors. If you could begin at the highest visible haze and drift downward like a silent instrument falling through the night, the first thing you would meet would not be drama, but thinning sunlight, cold gas, and delicate particles suspended far above the stronger cloud decks, where ultraviolet light from the distant sun and energetic particles interacting with the upper atmosphere help shape faint photochemical hazes that soften Saturn's colors and blur its bands. The air here would be almost entirely alien in composition, dominated by molecular hydrogen, with helium as the second great ingredient, along with small traces of methane, ammonia, phosphine, water vapor, hydrogen sulfide compounds, and other minor species whose faint spectral fingerprints allow scientists to read Saturn from afar. That reading is not simple looking, it is inference through light. Every color, every infrared glow, every absorption line is a clue, because no spacecraft has ever descended through Saturn the way the Galileo probe entered Jupiter. So much of what we know about Saturn's vertical atmosphere comes from spectroscopy, radio occultations, spacecraft imaging, thermal measurements, laboratory physics, and models that attempt to connect visible clouds to invisible depths. This makes the atmosphere more disturbing, not less, because it means the soft face we see is only the outermost sentence of a book written downward in pressure. At roughly the level where pressure is comparable to Earth's sea level pressure, scientists often place a reference altitude, but this is only a coordinate in a moving fluid, not a ground line. From there, as one imagines descending, the atmosphere begins to stack itself according to the cold arithmetic of hydrostatic balance. Pressure increases because every layer must support the weight of the gas above it, and the rate of that increase depends on density and gravity. So the deeper you go, the more the atmosphere becomes a silent force pressing inward from all sides. In a basic classroom model, one might describe this using the equation dP divided by dz equals negative density times gravity, a clean expression that feels harmless on paper, but inside Saturn, that equation becomes a pathway into suffocation by scale. It says with perfect calm that depth has consequences. It says there is no need for a wall or a blade or an explosion because the atmosphere itself becomes the weight. The first major cloud region likely involves ammonia ice, forming where temperatures and pressures allow ammonia vapor to condense into pale crystals, contributing to the light tones that make Saturn seem softer than Jupiter. Deeper still, at higher pressures and warmer temperatures, models suggest clouds involving ammonium hydrosulfide, and farther down, water clouds may form where the atmosphere is warm enough and pressurized enough for water vapor to condense far below the visible top. These layers are not clean shelves stacked in a museum display. They are broad, moving, uneven zones inside a rotating giant. Shaped by rising and sinking gases, chemical disequilibrium, sunlight from above, heat from below, and the tendency of condensation to release latent heat that can feed storms. In this way, Saturn's atmosphere becomes an ocean not of liquid water, but of buoyancy, phase changes, and hidden energy. On Earth, water vapor condenses into clouds and storms that we can watch roll across continents. On Saturn, similar thermodynamic principles operate in a hydrogen-helium world with different temperatures, pressures, and scales. So the familiar physics becomes strangely enlarged, stretched around a planet almost 10 times wider than Earth. A single convective tower, if it rises from deep enough, may carry information from regions we cannot see, like a dark well breathing upward through gold clouds. The planet's muted appearance can fool the eye into expecting quietness, but Saturn's upper atmosphere contains powerful east-west jet streams, broad zonal winds, and periodic storm systems, all influenced by rapid rotation. Because Saturn spins in about 10.5 hours, the Coriolis effect strongly organizes atmospheric motion, bending moving air into bands, jets, vortices, and wave patterns that do not behave like local weather on a human map. Here, the geometry matters. On a rotating sphere, motion cannot be understood as simple straight-line flow. It is shaped by latitude, angular momentum, pressure gradients, and the conservation of vorticity. So gases moving north or south are turned, stretched, and organized into planetary scale structures. The result is that Saturn's abyss is not merely vertical, but wrapped horizontally into belts of motion, as though the ocean without water were also a set of invisible rivers circling endlessly around the globe. And yet, unlike Earth's atmosphere, Saturn's weather has no continents to interrupt it, no mountain chains to tear it apart, no oceans with shores to define its boundaries. There are only deeper and shallower layers of the same planetary fluid, and that continuity allows motions to persist, couple, and evolve on scales that feel almost dreamlike. Beneath the cloud decks, the atmosphere becomes harder to separate from the interior. Hydrogen under increasing pressure becomes dense, and as temperature rises with depth, the gas enters regimes where ideal gas intuition weakens. The simple relation between pressure, temperature, and density that works reasonably well in ordinary air becomes insufficient, and scientists must use equations of state built from high-pressure physics, experimental data, and theoretical calculations. This transition from simple atmospheric science to deep planetary physics is one reason Saturn is so difficult to imagine honestly. At the top, you can speak of clouds and winds. Farther down, you must speak of non-ideal fluids, opacity, convection, helium behavior, and the transport of heat from the interior into space. Saturn radiates more energy than it receives from the Sun, which means the atmosphere is not merely warmed from outside like a cold stone under a weak lamp. It is also influenced by heat escaping from within, a leftover and ongoing planetary warmth that may involve slow cooling, gravitational differentiation, and possibly helium separating from metallic hydrogen regions at depth, though the details remain part of active research. That rising heat helps make the atmosphere a living physical engine, not alive biologically, but alive in the sense that it overturns, stratifies, cools, condenses, flashes, and releases energy according to rules older than any human observer. This is where the image of an abyss becomes almost exact. In Earth's ocean, light fades with depth until the surface world disappears. In Saturn's atmosphere, sunlight also weakens as clouds and haze absorb and scatter it. But instead of entering cold black water, you descend into pressure and warmth, into a region where the outside universe becomes less relevant, and the planet's own interior conditions begin to dominate. Above you, the rings would be gone from view. Around you, the golden disk would no longer look golden. The graceful planet of postcards would become a surrounding medium, featureless in one direction, turbulent in another, and increasingly opaque, until vision itself would be a poor instrument. The fear is not simply that a person could not breathe there, though of course there is no oxygen-rich air for human life. The fear is that the environment would gradually remove every familiar reference. No horizon, no ground, no open sky, no stable weather in the earthly sense, no depth gauge connected to a meaningful bottom. Instruments would record pressure levels, temperatures, chemical abundances, wind speeds, and perhaps electrical activity from storms. But the body would understand only one thing, that the world has become an all-sided descent. The history of studying this abyss is also a history of humility. Early telescopes showed shape and ring geometry, but not atmospheric depth. Voyager revealed more structure, more banding, more storm activity than distant images had suggested. Cassini, arriving centuries after Galileo's first puzzled view, watched Saturn through seasons, observed storms and thermal patterns, measured atmospheric waves and composition from orbit, and still left the deepest layers unseen. Each mission turned the planet from a symbol into a system. Yet each answer opened another pressure level below it. That is why Saturn's atmosphere is so unsettling in a scientific sense. It is accessible enough to model, image, and measure, but inaccessible enough to remain immense. It invites equations, but resists completion. It allows comparison to fluids, oceans, weather, and engines. But it is not truly any one of those things. It is a planetary abyss disguised as a sky. And perhaps the most disturbing part is that nothing about this abyss is unnatural. It does not violate physics. It fulfills physics. Gravity gathers the gas. Pressure supports it. Rotation organizes it. Heat moves through it. Condensation marks levels inside it. Light touches the top and leaves the rest to darkness and inference. Saturn's atmosphere is terrifying because it is not chaotic nonsense, but ordered depth. A place where the universe calmly demonstrates that a planet can be enormous, beautiful, mathematically coherent, and completely hostile to every instinct that tells us a world should have a bottom. So when we call Saturn's atmosphere an ocean without water and without a floor, we are not speaking only in poetry. We are naming the deepest fact of the planet's visible face, that the golden calm we admire is the upper skin of a descending continuum, a vast fluid night where the farther you fall, the less the word atmosphere means sky, and the more it means Saturn itself, waiting below without ever becoming land. The next layer of Saturn's fear begins when the stillness breaks. Not loudly, not suddenly, but in the slow realization that the soft bands wrapped around the planet are not painted lines on a quiet globe, but rivers of gas moving at planetary scale. Streams of hydrogen and helium flowing around a world so large that a storm can become a continent, a jet can circle the entire equator, and a single disturbance can grow until it seems to write itself across the face of the planet. From Earth, Saturn looks calm because distance smooths motion into silence. The eye sees cream, gold, faint gray, and amber, all blended into a sleepy lantern in the outer solar system. But this calm is a trick of scale and time. The atmosphere is moving, shearing, folding, overturning, and organizing itself under laws that are familiar in principle, yet enormous in expression. On Earth, wind is air responding to pressure differences, temperature contrasts, rotation, friction, and terrain. But Saturn has no continents to interrupt its flow, no mountain ranges to tear storms apart, no warm ocean basins with coastlines to limit their growth. Its weather does not move over a world. Its weather is part of the world, woven into the very body of the planet. And that makes every visible band less like a cloud pattern and more like the exposed current of a vast rotating machine. Near Saturn's equator, winds have been measured at extraordinary speeds, faster than the strongest hurricanes on Earth. And although values can vary depending on altitude, wavelength, and tracking method, the broad fact remains: Saturn's upper atmosphere can move with violence hidden beneath a gentle face. What makes this especially disturbing is not simply speed, but organization. Saturn rotates in roughly 10.5 hours, a very short day for a planet so immense. And that rapid spin strengthens the Coriolis effect, turning moving gas into long east-west jet streams instead of letting it wander freely from pole to pole. A parcel of gas rising or drifting within Saturn's atmosphere is not moving across a flat map. It is traveling on a rotating sphere, carrying angular momentum, responding to pressure gradients, and being deflected according to latitude. So the atmosphere naturally arranges itself into belts, zones, waves, vortices, and jets. The physics can be stated quietly. A rotating fluid tends to conserve potential vorticity, meaning that changes in depth, latitude, and spin are linked in ways that guide the motion into organized bands. Yet behind that clean phrase is a world where mathematics becomes weather large enough to swallow nations. If you watched Saturn from orbit, the cloud tops would seem almost slow at first because the scale is too large for ordinary perception. Then, over hours and days, the bands would shift, bright spots would stretch into streaks, darker features would rotate away, and the planet would reveal itself as a fluid sphere in motion. Not a sleeping object, but a layered atmosphere continuously sorting energy. The storms on Saturn are not merely larger versions of storms on Earth. They emerge from different reservoirs of heat and depth. Earth storms often draw energy from solar heating, warm oceans, water vapor, and surface contrast, while Saturn, far from the Sun, receives only weak sunlight compared with Earth and still radiates more energy into space than it receives. That interior heat, leaking upward through an atmosphere of mostly hydrogen and helium, gives Saturn's weather a strange independence from sunlight, as though the planet carries an old warmth inside itself and releases it through cloud, convection, and disturbance. Deep below the visible cloud tops, water vapor may play an important role in the largest storms, because water is heavier than hydrogen and helium and can affect stability in complicated ways. When deep, moist convection finally breaks through, it may release stored energy into the upper atmosphere, feeding enormous bright storms that rise from hidden depths. This is one reason Saturn can appear quiet for long stretches, and then suddenly produce a storm so large that it changes the appearance of an entire latitude band. These great outbreaks, often called great white spots, have been observed roughly once per Saturn year, which is nearly 30 Earth years, though the timing is not a perfect clock, and the underlying mechanism is still studied with care. The 2010 to 2011 storm became one of the most dramatic examples ever watched by spacecraft, a bright disturbance in Saturn's northern hemisphere that expanded, wrapped around the planet, and left a long-lived wake in the atmosphere. It was not a local thunderstorm in the way a person in Kansas or Florida would understand one. It was a planetary event, a convective eruption that disturbed the surrounding winds, generated complex waves, and changed thermal patterns high above the visible clouds. The scary part is that Saturn does not need a solid surface to have weather with this kind of memory. In fact, the lack of ground allows the atmosphere to behave like a deeper, freer ocean, where storms can interact with jets and waves without being quickly destroyed by mountains or continents. On Earth, friction with the surface drains energy from low-level winds. On Saturn, the bottom of the weather layer is not a rocky floor, but a transition into deeper fluid. So scientists have to ask how far the winds penetrate, how they are slowed, how they are connected to interior rotation, and how magnetic effects may eventually influence motion at great depth. Measurements from spacecraft gravity data suggest that Saturn's winds may extend thousands of kilometers downward, though not all the way through the planet. And that finding turns the visible atmosphere into the surface expression of a much deeper mechanical system. A cloud feature is not just a cloud feature. It may be the top of a column, a shear zone, a wave, or a current whose roots reach far below what sunlight can reveal. The storms also carry electricity. Saturn produces lightning, detected not only as flashes in some observations, but also through radio emissions known as Saturn electrostatic discharges. And the idea of lightning on a gas giant gives the night a different texture. Imagine thunderheads not rising above a prairie, but blooming inside a hydrogen atmosphere, hundreds or thousands of miles above any meaningful solid boundary. Their flashes buried in clouds of ammonia, water, and other compounds. Their radio whispers traveling into space to be caught by instruments. Lightning tells us that charge separation, convection, and cloud microphysics are active there. But it also reminds us that Saturn's beauty contains violence that the eye cannot always see. A golden band might be quiet in visible light, while deeper clouds are charging, rising, collapsing, and releasing energy. At high latitudes, the story becomes even stranger. Vortices form near the poles, and Saturn's polar regions show organized structures shaped by rotation and atmospheric dynamics, including the famous northern hexagon, which belongs more fully to another chapter, but already hints here at an unsettling truth. Storms and winds on Saturn can become geometric. This is not magic, and it is not design. It is fluid dynamics operating under extreme scale, where waves in a jet stream can lock into persistent patterns. The disturbing thing is that nature does not need intention to create forms that look deliberate. It only needs the right equations, the right boundary conditions, the right rotation rate, and enough time. That idea gives Saturn's weather a cold intelligence, not because it thinks, but because it organizes itself with a precision that feels almost thoughtful from a human distance. The wind belts, storm outbreaks, polar vortices, wave trains, and long-lived disturbances all belong to a system governed by conservation laws. Conservation of mass, conservation of momentum, conservation of energy, and the thermodynamic rules that decide when gas rises, condenses, warms, cools, and sinks. These laws are not violent in language, but they are absolute in consequence. A human body in those winds would not experience the elegance of the mathematics. It would experience an environment with no shelter, no breathable air, no stable surface, and no escape from motion that extends beyond the horizon in every direction. Even a spacecraft would not fly through weather in the familiar sense for very long. It would enter layers of increasing pressure, changing density, and powerful shear, where communication, heating, structural load, and navigation would become problems written by the atmosphere itself. And still, from Earth, all of this is softened into beauty. That is the deep unease of Saturn's storms. They are not obvious monsters. They hide inside grace. Jupiter shows its violence more boldly, with the great red spot glaring like an ancient wound. But Saturn keeps much of its unrest under pastel veils, under haze, under low contrast, under the quiet dignity of distance. Its storms are frightening because they reveal a universe where calm appearance and extreme motion can occupy the same body without contradiction. The planet can look asleep while its atmosphere moves faster than earthly hurricanes. It can look smooth while deep convection builds in darkness. It can look timeless while seasonal changes slowly alter temperatures, colors, and storm behavior across decades. It can look like a symbol of peace while hosting winds that are not weather passing over land, but weather wrapped around a world without land. And when you understand that, the rings no longer seem to surround a quiet planet. They seem to frame a vast atmospheric engine, turning in the dim light, breathing heat from below, shaping clouds into bands, letting storms rise like pale ghosts from hidden depths, and then stretching them around the curve of a globe too large for the mind to hold at once. Saturn is scary in this chapter because it teaches that silence is not the absence of motion. Sometimes silence is only what enormous motion sounds like from very far away. The most unsettling feature on Saturn is not hidden in darkness, not buried deep beneath the clouds, and not concealed inside the rings. It sits openly at the North Pole, quietly turning, a vast six-sided pattern in the atmosphere that looks at first like it should not belong to a natural world. When spacecraft images revealed the northern hexagon, the effect was strangely different from seeing a storm, a crater, or a ring gap, because those things feel chaotic or broken in familiar ways, while the hexagon feels composed, almost architectural, as if geometry itself had risen out of gas. It is a six-sided jet stream wrapped around Saturn's polar region, roughly 20,000 miles across, large enough to hold several Earths within its boundary, and yet it keeps a recognizable shape, not for minutes or hours, but across decades of observation. That persistence is what makes it disturbing. A spiral storm can be frightening because it looks violent, but a hexagon is frightening because it looks intentional, and science has to move carefully through that emotional illusion, showing that intention is not required for nature to produce symmetry. On Saturn, the ingredients are rotation, stratified atmosphere, pressure gradients, temperature contrasts, wave dynamics, and time. Put them together on a giant fluid planet with no solid surface, and the result can be a shape that seems drawn, even though no hand has drawn it. The hexagon was first noticed in Voyager images during the early 1980s, when humanity's view of the outer planets was still transforming from telescope sketches into close-range planetary weather. And later, the Cassini spacecraft returned to Saturn and watched the structure with far greater detail across seasons, wavelengths, and lighting conditions. During Saturn's long northern winter, the pole was partly hidden from visible light cameras, but infrared instruments could still sense heat patterns, letting scientists continue tracing the strange outline in the dark. That historical detail matters because it shows the hexagon is not a brief optical trick. It is a real atmospheric structure seen by different instruments at different times, surviving long enough to become one of the most famous, unsolved-looking, yet physically grounded features in the solar system. The word unsolved must be used gently here, because the hexagon is not unexplained in the sense of mystery without physics. Researchers have strong frameworks for understanding it as a wave pattern associated with a powerful eastward jet near Saturn's north polar region. But the exact reasons for its longevity, sharpness, vertical structure, seasonal behavior, and detailed shape remain active subjects of modeling and interpretation. The most accepted direction of thought points toward fluid dynamics. The hexagon is likely a standing wave or meander in a jet stream, a pattern in which the flow bends into 6 large lobes while circling the pole. On Earth, jet streams also meander, forming waves that guide weather systems across continents. But Earth's atmosphere is interrupted by land, mountains, oceans, changing surface heating, and friction near the ground. Saturn has no ground in the human sense, no continents to break the wind, and its rapid rotation gives atmospheric motion a disciplined geometry, bending flows into bands and strengthening the influence of the Coriolis effect. In such a world, a jet stream can become more than a fast river of air. It can become a boundary, a waveguide, a rotating wall of momentum separating one polar region from another. The mathematics beneath this is calm and severe. In rotating fluids, large-scale motion is shaped by the conservation of potential vorticity, a quantity that links spin, latitude, and the thickness or stratification of the fluid layer. When a jet forms on a rotating sphere, Disturbances along it can behave like Rossby waves, broad planetary waves that owe their restoring force to the change in the Coriolis effect with latitude. In simplified models, the atmosphere can be treated as a shallow layer on a rotating sphere. And from that modest starting point, one can derive wave behavior, instabilities, and preferred patterns. But Saturn pushes the model into deeper territory. Because the atmosphere is not a thin sheet over rock, it is the visible upper part of a vast fluid planet, with cloud layers, thermal gradients, and winds that may extend thousands of miles downward. The hexagon, therefore, becomes a bridge between simple mathematics and advanced planetary science. A child can count its 6 sides. A physicist must ask what jet speed, latitude, stratification, viscosity, vertical shear, thermal forcing, and boundary conditions allow 6 sides rather than 5, 7, or an irregular wave train. Laboratory experiments with rotating tanks have produced polygon-like flows under certain conditions, showing that rotating fluids can organize into stable geometric patterns without anything supernatural. But Saturn is not a tank on a table. Its scale, composition, heat flow, and deep atmosphere make the real system far richer than any simple demonstration. This is why the hexagon remains so captivating. It can be approached by equations, but it does not become ordinary when explained. If anything, the explanation makes it more eerie, because it shows that the universe can manufacture order from motion with no intention at all. At the center of the hexagon lies another structure, the North Polar Vortex, a deep rotating storm system with an eye-like form and towering clouds, giving the region the feeling of a storm inside a geometric frame. This nesting of shapes is part of the unease. The outer boundary is angular, a 6-sided river of wind. The inner region is circular and cyclonic, a rotating polar eye. Around and above them, hazes and cloud features shift with Saturn's seasons. In visible light images, the hexagon can appear blue, gold, or muted depending on filters, sunlight, and atmospheric haze. But its real nature is not color. Its real nature is motion. Gas is flowing along a path that maintains corners. Of course, the corners are not sharp like a metal object, and the sides are not rigid walls. They are broad bends in a moving atmosphere, places where the jet's path changes direction across thousands of miles. But from above, the pattern is clear enough to disturb the mind, because we associate polygons with crystals, machines, temples, maps, things built from edges and design. A polygon made of wind forces us to update that instinct. It tells us that geometry is not always solid. Sometimes geometry is a behavior. Sometimes a shape is what motion becomes when rotation, pressure, and scale negotiate for long enough. The scary part is not that Saturn's hexagon breaks the rules of nature, but that it follows them so beautifully that it appears unnatural. This is a deeper kind of fear than chaos. Chaos is easy to dismiss as wildness. Order is harder, because order asks us to accept that the same universe that gives us snowflakes, spiral galaxies, hurricanes, and orbital resonances can also draw a hexagon around the pole of a gas giant. The pattern also reminds us that Saturn's atmosphere has layers of time. Earth weather changes quickly in human memory. Storms come and go, fronts pass, seasons turn. Saturn's seasons last more than 7 Earth years each, because its orbit around the Sun takes nearly 3 decades. The North Pole moves from long winter darkness into sunlight slowly, and the atmosphere responds with changes in color, haze, temperature, and circulation that are not yet fully understood in every detail. Cassini watched some of this transformation, giving scientists a rare view of a giant planet's polar atmosphere waking into light. But even 13 years in orbit could not cover a full Saturn year. That limitation gives the hexagon a haunting patience. It has existed longer than our close observation of it, and it will continue evolving beyond the missions that made it famous. We are not watching the whole story. We are reading a few luminous pages from a climate system whose clock is slower than ours. In that sense, the hexagon is not only a storm feature, but a lesson in humility. It shows how difficult it is to understand a planet when one human lifetime covers only a few of its seasons. When the atmosphere is too deep to sample directly, and when the most precise models still have to simplify a reality made of compressible gas, turbulent flow, radiation, cloud chemistry, and possible coupling to deeper interior motions. The more carefully one studies it, the less it feels like a curiosity, and the more it feels like a signature of Saturn's entire nature. Beautiful at a distance, fluid underneath, mathematically ordered, physically extreme, and deeply indifferent to whether its order comforts or unsettles us. If a spacecraft could hover above the North Pole and look down through the dim sunlight, the hexagon would not roar like a monster in a story. It would turn with enormous calm. The winds would move around the boundary. Clouds would drift along the sides. Smaller vortices and waves would appear and vanish. The central polar storm would rotate in silence, and all of it would be happening on a world where there is no surface below, only deeper atmosphere and pressure. That is the final reason the northern hexagon feels so disturbing. It is not just a strange shape. It is a reminder that Saturn's terror is not messy. It can be elegant. It can be stable. It can be symmetrical. It can look like a symbol carved into a planet, while being nothing more and nothing less than fluid obeying physics in a place too vast and too cold for human intuition. The hexagon makes Saturn feel watched, not because anything is watching, but because the pattern is so calm that the human mind tries to put meaning into it. And then science quietly takes that meaning away, replacing it with something even more profound. A six-sided storm at the edge of sunlight, drawn by wind, held by rotation, measured by spacecraft, still not completely exhausted by theory, and turning patiently over a world that never needed to be strange for us, yet became one of the strangest places we have ever seen. Saturn's rings are the part of the planet that makes people fall in love first, and that is why they may be the most deceptive part of all. Because from Earth they seem peaceful in a way almost nothing else in the solar system does. A pale, shining ellipse laid around a golden world, thin as a blade of light and smooth as if it had been polished by time. But the closer science brings us to them, the more that beauty begins to feel less like decoration and more like wreckage arranged by gravity. The rings are not solid, not a crystal band, not a bridge, not a halo in the spiritual sense, and not a flat road that could ever carry a human foot. They are a vast collection of particles, mostly water ice, with varying amounts of darker, rocky, and dusty material, ranging from grains smaller than sand to chunks that can be compared to houses or hills, all orbiting Saturn at different speeds, according to their distance from the planet. From far away, countless separate fragments blur into one luminous sheet, just as a snowstorm at night can look like a white wall when each flake is really falling alone. And this is the first quiet disturbance. The smoothest looking structure in the solar system is made of pieces that are never truly still. Every particle is falling around Saturn, missing the planet again and again, held in orbit by the exact balance between forward motion and inward gravity. The simple Newtonian idea is almost gentle on paper. An object in orbit is continuously falling, but its sideways speed carries it around the central body. And if the orbit is stable enough, the fall becomes a circle or an ellipse. Yet in Saturn's rings, that calm equation becomes an enormous moving population of ice, a thin, glittering disk where billions upon billions of particles follow paths shaped by collisions, tides, resonances, moonlets, shadows, sunlight, and electromagnetic effects. The horror is not loud, because the rings do not roar in the vacuum. They do something stranger. They continue. They circle Saturn with a patience that makes destruction look graceful. Historically, the rings were unsettling even before they were understood. Galileo saw Saturn through his early telescope in 1610 and could not resolve the true structure, describing the planet as if it had strange side bodies or handles, because the instrument was not powerful enough to reveal a ring. Christian Huygens later proposed a thin, flat ring surrounding Saturn without touching it, and Giovanni Domenico Cassini identified a major gap that showed the ring was not a single simple band. Each advance in observation made Saturn less mythical and more physically precise, but the precision did not make it ordinary. It revealed that this delicate-looking ornament was actually a dynamic system. The Cassini division, the Encke gap, the narrow ringlets, the faint outer structures, the bright A and B rings, the dusky C ring, and the tenuous E ring, all tell a story of matter being sculpted by forces that do not need hands. Saturn's rings appear flat because orbital systems tend to damp away vertical motion through countless small collisions, slowly settling particles into a shared plane, much as a swarm of restless objects, after enough interactions, loses its upward and downward excess and becomes a disk. That disk lies close to Saturn's equatorial plane, bound to the geometry of the planet's rotation and gravity field, and the result looks impossibly clean. A structure that can stretch hundreds of thousands of miles across while remaining astonishingly thin compared with its width. This ratio is one of the most disturbing facts about the rings. They are not thick walls in space. They are more like a cosmic sheet, broad enough to dwarf Earth, yet thin enough in many regions to make the word fragile feel appropriate, even though everything inside that fragility is moving at orbital velocity. A spacecraft passing through the ring plane would not encounter a polished surface. It would enter a region where emptiness dominates most of the volume, but where small particles still travel fast enough to threaten machinery, and where the apparent softness of ice hides the violence of relative motion. The rings are beautiful because the particles are mostly bright ice, reflecting weak sunlight from the outer solar system. But ice in orbit is not gentle simply because it shines. It is matter under command. Here, the Roche limit becomes one of the central ideas, a quiet mathematical boundary where Saturn's tidal forces can prevent loose material from gathering into a large moon. The basic principle is that gravity from Saturn pulls more strongly on the near side of an object than on its far side. And if that difference becomes strong enough, a weak body can be torn apart or prevented from clumping together. The exact limit depends on density, material strength, and internal structure. So it is not a single magical line for every object. But the concept explains why a ring system can exist close to a giant planet. The same gravity that gathers worlds can also refuse to let one form. This is where the rings begin to feel like a graveyard, though science must hold that word carefully. Their origin is still debated. They may be the remains of an icy moon or comet-like body torn apart by tides, shattered by collision, or disrupted through some more complex sequence of events. They may be relatively young compared with Saturn itself, or they may have evolved through processes that make age difficult to interpret from brightness alone. Cassini measurements, contamination rates, ring mass estimates, and models of micrometeoroid darkening have all contributed to the debate. But the safest truth is that the rings are not a frozen museum display. They are changing. They are being bombarded by tiny meteoroids, darkened by dust, spread and confined by gravitational interactions, and slowly losing material into Saturn's atmosphere in a process often described as ring rain. In that sense, their beauty may be temporary on astronomical timescales, a luminous phase in a long story rather than an eternal crown. The rings also behave like a laboratory for celestial mechanics, because within their thin plane, scientists can see waves, gaps, edges, clumps, wakes, and spiral patterns that resemble equations made visible. When a moon orbits near a ring, its gravity can create resonances, locations where the orbital periods of ring particles and moons fall into repeating ratios. These resonances can clear gaps, pile material into waves, or maintain sharp edges. Mimas helps shape the Cassini division through resonance. Pan and Daphnis move within gaps and disturb nearby ring material, creating scalloped edges, vertical structures, and wave patterns that look delicate from far away, but are really the handwriting of gravity. Small embedded moonlets can create propeller-shaped disturbances, where their gravity is strong enough to disturb nearby particles, but not clear a full gap. These details matter because they show the rings are not passive debris. They are a disk constantly negotiating with moons, with Saturn's uneven gravity, with collisions between particles, and with the slow exchange of angular momentum. In a simple model, each particle follows Kepler's laws, moving faster when closer to Saturn and slower when farther out. In a richer model, those particles collide, spread, bunch, resonate, scatter, cast shadows, absorb sunlight, cool by radiation, and respond to electromagnetic and plasma environments. The basic mathematics of orbit becomes a many-body problem, and the many-body problem becomes a shimmering, structured disk around a planet with no solid surface. That progression from simple ellipse to complex system is part of what makes the rings academically beautiful and emotionally unsettling. They are understandable enough to be studied with precision, but vast enough that understanding them does not make them feel safe. Even their shadows are ominous. As Saturn moves through its long seasons, the rings tilt toward and away from the Sun as seen from Earth, and they cast broad shadows across the planet's cloud tops, while the planet itself casts darkness back across the rings. During equinox, when sunlight strikes the ring's edge on, small vertical structures can cast long shadows, revealing that the thin disk is not perfectly flat, but contains ripples, disturbances, and raised features. This is a rare kind of seeing. Not the ring as symbol, but the ring as terrain made of countless separate orbits. And yet, it is not terrain you can walk on. That contradiction keeps returning. The rings look like a place, but they are not a place. They look like one object, but they are a population. They look eternal, but they may be fading. They look gentle, but they are built from fracture, confinement, and motion. If Saturn itself is frightening because it has no ground, its rings are frightening because they imitate structure without offering solidity. They are the universe's most elegant warning that order does not always mean peace. A broken moon, if that is part of their origin, can become a shining disk. Collisions can become pattern. Tidal forces can become beauty. Gravity can take debris and arrange it so perfectly that a person on Earth, looking through a small telescope in a quiet backyard, feels comfort instead of dread. But the comfort comes from distance. Up close, the halo becomes ice. The ice becomes orbit. The orbit becomes velocity. And the velocity becomes danger. Saturn's rings are therefore not accessories to the planet's sphere. They are one of its deepest expressions. They show that Saturn does not merely possess beauty. It manufactures beauty from forces that would destroy ordinary bodies, from tidal stress, shattered material, resonant pulling, endless motion, and the slow fall of particles into a pattern thin enough to look impossible. And as those rings circle silently in the weak sunlight, bright against black space, they make Saturn more disturbing, because they prove that the universe can turn ruin into symmetry, and that something can be breathtaking not despite being violent in origin, but because the violence has been stretched, cooled, and organized until it shines. The frightening thing about Saturn does not end at the edge of its clouds, or even at the farthest visible ring, because the planet also owns a region of space that cannot be seen by human eyes, a vast magnetic kingdom stretching outward into darkness, filled with charged particles, plasma, radiation belts, invisible currents, radio emissions, and electrical relationships between the planet, its rings, its moons, and the solar wind. If Saturn's atmosphere is an abyss you could fall into, its magnetosphere is the abyss you could enter without realizing you had crossed a border. There is no wall, no color change, no shining gate around the planet where the magnetic field begins to matter. A spacecraft drifting towards Saturn would simply move from interplanetary space into a different physical regime, one where the rules are no longer set only by gravity and sunlight, but also by fields and charged particles that curve, trap, accelerate, and guide matter along invisible lines. This is why Saturn becomes more disturbing the more deeply we understand it. Even the emptiness around it is not empty. Space near Saturn is a system, and the planet is not just a globe with rings, but a rotating electromagnetic engine, quietly sculpting its surroundings far beyond the place where its golden clouds can be seen. The basic source of this hidden power lies deep inside Saturn, where electrically conducting material moves within the planet and generates a magnetic field through a dynamo process. On Earth, the dynamo is usually connected to motion in the liquid outer core. But Saturn is a gas giant, and its interior is dominated by hydrogen and helium under immense pressure. Deep enough inside, hydrogen is thought to enter a metallic, electrically conducting state, and the movement of this conductive fluid, shaped by rotation and convection, can maintain a global magnetic field. The exact internal structure remains an active scientific question, especially because Saturn's magnetic field is unusually aligned with its rotation axis, far more closely than Earth's or Jupiter's, and that near alignment created a historical puzzle. Scientists often estimate a planet's deep rotation by watching periodic changes in its magnetic field. But Saturn's field is so symmetrical that it does not easily provide a simple clock. That one detail is quietly unsettling, because it means even Saturn's magnetism, something we can measure with instruments, hides the planet's interior rather than revealing it completely. The field reaches outward and forms a magnetosphere, a magnetic bubble created where Saturn's planetary magnetic pressure pushes against the stream of charged particles flowing from the Sun. The solar wind is thin, but it is never nothing. It carries plasma and magnetic field through the solar system, and when it encounters Saturn, the interaction creates boundaries such as a bow shock and magnetopause, where the flow changes, compresses, and redirects. In a simple drawing, this magnetosphere looks like a bubble with a long tail swept away from the Sun. But the real structure is dynamic, breathing in response to solar wind pressure, rotating with Saturn's internal field, and being filled from within by material supplied by the planet's moons and rings. This is where Saturn's invisible space becomes unlike Earth's in a deeply fascinating way. Earth's magnetosphere is strongly influenced by the solar wind, but Saturn has an internal plasma source of extraordinary importance. Enceladus, a small icy moon that sprays water vapor and ice grains from fractures near its south pole. Some of that material feeds Saturn's broad E-ring, and some becomes ionized, turning from neutral molecules into charged particles that are picked up by Saturn's magnetic field. Imagine a moon quietly breathing water into space, and a giant planet turning that breath into plasma. It sounds poetic, but it is physics. Neutral particles do not strongly follow magnetic fields. Yet, once they're ionized by sunlight, electron impacts, or charge exchange, they begin responding to electromagnetic forces, and Saturn's rotating magnetic field can sweep them along, creating a plasma environment that is both delicate and immense. In this region, matter does not move only because of gravity. It gyrates around magnetic field lines, drifts through electric fields, exchanges charge, collides, spreads, and becomes part of a rotating disk of plasma around Saturn. The mathematical language of this realm is different from the language of falling stones and orbiting moons. Newton's gravity is still present, always present, but charged particles obey the Lorentz force, where electric and magnetic fields alter their motion, bending their paths into spirals and guiding them along invisible structures. To a human mind, this feels ghostly because the forces are silent and unseen, yet to a particle they are as real as a road. Saturn's magnetic field becomes architecture without walls. Its magnetosphere contains radiation belts, regions where energetic, charged particles are trapped and bounce along magnetic field lines, and these regions can pose serious risks to spacecraft electronics. Saturn's radiation environment is generally less intense than Jupiter's most extreme belts, but that does not make it gentle. It is still a hostile region of charged particles, energetic electrons, ions, plasma waves, and complex interactions with moons and rings. The rings themselves act not merely as scenery, but as absorbers, boundaries, and sources within this system. They can remove charged particles that collide with ring material, shape radiation belts by carving out particle populations, and participate in an electrical relationship with the planet's upper atmosphere. Even the rings cast shadows that alter ionization in Saturn's atmosphere, linking light, chemistry, and electromagnetic behavior in a way that makes the entire Saturn system feel like one immense connected instrument. The moons add further complexity. Titan, with its thick, nitrogen-rich atmosphere, interacts with Saturn's magnetospheric plasma as it orbits within or near the outer regions of the magnetic environment, depending on solar wind conditions. Enceladus supplies water group ions. Other moons sweep up particles or create wakes. The result is not a simple magnetic bubble surrounding a lonely planet, but a living physical network where a moon can feed a ring can affect plasma, plasma can generate waves, waves can influence particle motion, and the planet's rotation can attempt to drag the whole system into motion with it. This is one reason Saturn feels more disturbing than a mere object. It behaves like an environment with many invisible layers. You can look at a photograph and see a golden planet, a ring plane, and tiny moons. But the photograph does not show the magnetic lines threading through the scene, the charged particles spiraling along them, the radio emissions whispering into space, or the auroras glowing near the poles where energetic particles enter the upper atmosphere. Saturn has auroras, not exactly like Earth's, but related in principle, produced when charged particles and currents interact with the upper atmosphere and magnetic field. On Earth, auroras can look gentle, green curtains over polar skies. But at Saturn, they reveal a planet-scale electrical circuit, a conversation between rotation, plasma, solar wind, and atmosphere. In ultraviolet and infrared observations, those auroral regions become evidence that the planet's poles are not just places on a globe, but openings into an electromagnetic system. And because Saturn rotates rapidly, the magnetosphere is not simply sitting still in space. The planet's rotation tries to pull plasma around with it, enforcing a kind of co-rotation that becomes harder with distance, as particles farther out require greater speed to keep pace. Where perfect co-rotation breaks down, currents and stresses develop, and the system becomes a place of exchange between rotational energy and particle motion. This is not dramatic in the way a collision is dramatic. It is more like a silent machine redistributing energy through fields. The academic beauty is deep here, because Saturn's magnetosphere can be studied through magnetohydrodynamics, plasma physics, field-aligned currents, wave-particle interactions, and boundary dynamics with the solar wind. But the emotional effect is simple. The planet's influence extends into places that appear empty. A spacecraft may be far above the clouds, nowhere near the rings, with black space on every side, and still be inside Saturn's invisible weather. This hidden weather can compress, expand, fluctuate, and emit radio waves. It can be disturbed by solar storms from far away at the sun. It can be fed by an icy moon, It can be measured only by instruments designed to feel what eyes cannot see. That is the core of the fear in this chapter. Saturn is not contained by its image. The beautiful disk is only the visible center of a much larger domain. The rings are not the outer boundary. The moons are not merely ornaments. The space between them is not a blank stage. It is filled with laws, fields, particles, and exchanges so quiet that they seem almost dreamlike, until one remembers that they can damage spacecraft, alter atmospheres, shape observations, and carry the planet's presence outward into the dark. This is how Saturn teaches another form of cosmic unease. The universe does not need to show its power in visible matter alone. Some of its most important structures are invisible until mathematics and instruments reveal them. A magnetic field has no color, yet it can trap radiation. Plasma is thinner than any air a person could breathe, yet it can carry currents across enormous distances. A tiny moon can spray vapor into vacuum, and that vapor can become part of a giant planet's electromagnetic body. A ring can shine like frost and still participate in electrical and particle processes too subtle for the eye. So when we imagine Saturn as the scariest planet, we should not picture only falling into its atmosphere or being lost among its rings. We should picture approaching a world whose unseen reach begins long before touch, a world surrounded by a magnetic night where particles spiral silently, auroras pulse above the poles, Enceladus feeds a ghostly plasma disk, and the planet's deep interior sends its influence outward through a field so symmetrical and secretive that it still keeps part of Saturn's rotation hidden from us. Saturn is disturbing because it proves that emptiness can belong to a planet, that space itself can be shaped into an invisible environment, and that long before you ever reach the clouds, you may already be inside the quiet machinery of a world that has been holding the darkness around it for billions of years. The strangest thing about Saturn may not be Saturn itself, but the small worlds moving around it in silence. Because after everything that makes the planet feel impossible for life, the bottomless hydrogen atmosphere, the crushing depths, the storms without land, the rings made of shattered ice, the invisible magnetic field surrounding it like a ghostly machine, we arrive at Titan and Enceladus, and the story turns in a way that is almost more disturbing than pure hostility. Saturn, the great cold monarch of the outer solar system, may be unlivable in the ordinary sense, but within its domain are moons that seem to whisper a more uncomfortable possibility, that the ingredients for life may not belong only to warm blue planets close to sunlight, that chemistry may keep working in darkness, that oceans may hide under ice, and that the universe may be more inventive than the narrow instincts of earth-born creatures ever expected. Titan is the larger and more dreamlike of the two, a moon bigger than Mercury, wrapped in a thick, nitrogen-rich atmosphere, so dense that, if you stood there in a suit built for the cold and chemistry, the sky would not be black, but orange-brown, veiled by organic haze created when sunlight and charged particles break apart methane and nitrogen high above the surface, allowing fragments to recombine into more complex carbon-bearing molecules. This is not life, and it should never be described as life, but it is the kind of chemistry that makes astrobiologists lean closer. Because carbon chemistry is the alphabet from which living systems on Earth are written, and Titan is covered in that alphabet in a frozen, alien dialect. Its surface is brutally cold, near minus 290 degrees Fahrenheit, cold enough that water behaves not like liquid but like stone, forming icy bedrock beneath dunes, plains, channels, and shorelines shaped by materials that would be gases on Earth. The rivers and lakes on Titan are not water. They are mostly liquid methane and ethane, hydrocarbons flowing under a dim sun, raining from clouds, gathering into dark northern seas, evaporating, condensing, and falling again in a cycle that resembles Earth's hydrological cycle only in structure, not in substance. That resemblance is what makes Titan unsettling. It is familiar and wrong at the same time. It has weather, but the rain is methane. It has shorelines, but the seas would not carry earthly fish. It has dunes, but the sand may be made of organic particles, dark grains slowly shaped by winds under a sky the color of old amber. It has a thick atmosphere, but not one we could breathe. Titan is not a second Earth. It is a reminder that the grammar of a planet-like world can be rearranged with different nouns. Rain does not have to mean water. Rock does not have to mean silicate. A river does not have to be warm. A landscape can look almost understandable while being chemically foreign from horizon to horizon. Beneath that cold surface, evidence suggests Titan may also hide a global ocean of liquid water mixed with salts and perhaps ammonia, separated from the surface by a thick shell of ice. And this possibility shifts Titan from strange chemistry into deeper astrobiological territory. On Earth, liquid water is closely tied to life because it is an excellent solvent, able to support the transport of ions and molecules, stabilize complex chemistry, and allow reactions to occur in ways that dry environments cannot. But on Titan, if a deep water ocean exists, it is sealed away beneath ice, cut off from the orange skies and methane lakes above, raising questions about energy, nutrients, exchange, and whether surface organics could ever reach the ocean in meaningful amounts. Some models explore impacts, cryovolcanism, fractures, or slow geologic cycling as possible pathways, but there is no simple certainty. Titan's fear is therefore not the fear of a monster beneath the ice. It is the fear of a question too large to answer from afar. Could chemistry in a frozen moon, far from the sun, create prebiotic complexity on the surface and perhaps maintain a hidden water environment below? Could life, if it ever exists elsewhere, adapt to conditions that would seem absurd from an Earth-centered view? Or is Titan a grand chemical theater, rich in ingredients, but missing the right energy pathways, the right mixing, the right conditions for biology to cross the threshold from possibility into reality? The honest answer is that we do not know, and that uncertainty is more powerful than exaggeration. Enceladus, by contrast, is small, bright, and almost modest at first glance, a moon only about 300 miles across, shining with fresh ice so reflective that it looks clean and quiet against the darkness. But near its south pole are long fractures nicknamed tiger stripes, and from those fractures, Enceladus sprays plumes of water vapor, ice grains, salts, and organic molecules into space. This is one of the most astonishing discoveries in planetary science, because Enceladus is not merely suspected of holding water. It is actively leaking material from its hidden ocean into the space around Saturn, giving spacecraft a chance to taste, indirectly, what lies beneath the ice. Cassini flew through those plumes and detected evidence that points toward a subsurface, salty ocean in contact with a rocky interior, along with molecular hydrogen, organic compounds, and other chemical clues that suggest water-rock interactions may be occurring at depth. Molecular hydrogen is especially important because, on Earth, it can be produced by reactions between water and certain rocks, and can serve as a source of chemical energy for microbes in environments without sunlight, such as hydrothermal vent systems on the sea floor. Again, this is not evidence of life on Enceladus, but it is evidence of conditions that make the Moon one of the most compelling places to think about habitability beyond Earth. The word habitability must be handled carefully. It does not mean inhabited. It means that some of the known requirements for life as we understand it may be present: liquid water, essential chemical elements, and usable energy. Enceladus appears to offer a possible combination of these in a place that should have seemed, at first, too small and too cold to matter. The heat that helps maintain its ocean is likely connected to tidal forces, the repeated gravitational flexing caused by interactions with Saturn and neighboring moons, especially through orbital resonance. This is a profound idea, because it means sunlight is not the only way to keep a world geologically or chemically active. Gravity itself can become a kind of hidden furnace. A small moon can be kneaded by orbital mechanics, warmed from within, and kept alive as a physical system long after simple distance from the sun would suggest stillness. Here the mathematics of life's possibility changes. In the older, simpler view, habitability was often imagined as a ring around a star, the so-called habitable zone, where a planet might hold liquid water on its surface. That idea remains useful, but moons like Europa and Enceladus forced science to widen the frame. A world can lie far outside the classical habitable zone and still maintain an internal ocean if tidal heating, radiogenic heat, antifreeze chemistry, pressure, and ice shell dynamics work together in the right way. This does not make life common, and it does not guarantee biology in the outer solar system, but it breaks the old emotional map. It tells us that the places most worth searching may not be the warm places we can easily see, but the hidden places that leak clues through cracks. This is why Titan and Enceladus make Saturn more frightening rather than less. Pure emptiness is simple. A dead world is easy to file away in the mind. But a hostile system that also contains possible habitats is harder to understand. It becomes morally and scientifically delicate. Cassini was ultimately sent into Saturn's atmosphere in part to avoid any future chance of contaminating moons like Enceladus or Titan, a decision that reveals how seriously scientists treat these environments. The spacecraft had spent years revealing their mysteries, and then it was guided into destruction so that it would not accidentally disturb the very worlds it had helped make precious. There is something quietly haunting about that. A machine from Earth dying in the sky of Saturn because small icy moons nearby had become too scientifically sacred to risk. Titan and Enceladus also deepen the central thesis of Saturn's fear, because they show that the Saturn system is not merely beautiful and deadly, it is ambiguous. It refuses to fit into a single emotional category. Saturn itself is a bottomless giant that no human could land on. Its rings are bright debris shaped by gravity. Its magnetosphere is an invisible field of charged particles. Yet within this cold kingdom, one moon has methane weather and organic haze, and another throws ocean material into space like a message from beneath the ice. The scariest thought is not that life is definitely there. The scariest thought is that the universe may allow life's ingredients to gather in places that look utterly unwelcoming, and that our sense of where life belongs may be a provincial habit formed under one yellow sun, on one wet rock, during one small era of cosmic time. Titan asks whether complex chemistry can unfold in a frozen atmosphere under orange skies. Enceladus asks whether a dark ocean, warmed by tides and pressed against rock, can become chemically alive without sunlight. Together, they turn Saturn from a single frightening planet into an entire philosophical system. They make us imagine biology not as a garden under blue daylight, but as a possibility hiding under ice, drifting in plumes, dissolved in black water, or written in hydrocarbons beneath a dim and distant sun. And so Saturn becomes disturbing in a deeper way than destruction alone could ever be. It is not simply a place that would kill us. It is a place that may be teaching us that life, if it exists beyond Earth, might not care about our expectations, our comfort, or our need for familiar skies. Around the most beautiful and unlivable giant, two small moons quietly keep their secrets. And in that contrast, there is a strange, sleepy terror. The universe may be colder, darker, and more indifferent than we hoped, yet also more fertile, more patient, and more mysterious than we are ready to understand. Cassini makes Saturn frightening in a different way, because until Cassini arrived, much of Saturn's terror was still softened by distance, wrapped in telescope light, reduced to a golden planet with rings in schoolbooks and quiet backyard eyepieces. But Cassini crossed that distance, entered the Saturn system, lived there for years, measured the planet with instruments instead of wonder alone, and then, when its work was almost finished and its fuel was running low, was deliberately sent into the atmosphere of the world it had spent more than a decade trying to understand. There is something deeply unsettling about that ending, not because it was reckless, but because it was precise. Cassini did not fail into Saturn. It was guided there. It became the first human-made spacecraft to orbit Saturn, and in its final act, it turned itself into a scientific instrument, falling into the very abyss that makes the planet so disturbing. No surface, no return path, only clouds, pressure, speed, heat, and the final thinning thread of radio signals traveling back across more than 1 billion kilometers of space. The story began long before that last descent, on Earth, where engineers and scientists built a spacecraft large enough to carry cameras, spectrometers, plasma instruments, a magnetometer, radar, radio science equipment, dust analyzers, and the European Huygens probe, all packed into a machine that had to survive years in interplanetary space and then operate in the cold, faint sunlight of the outer solar system. Cassini launched in 1997, but it did not fly straight to Saturn like an arrow. A direct path would have demanded more energy than was practical, so the mission used gravity assists, turning planets into quiet engines. It flew past Venus twice, then Earth, then Jupiter, each encounter exchanging a little orbital energy and reshaping the spacecraft's path with the mathematics of celestial mechanics. This is one of the elegant truths of spaceflight. A spacecraft can and reshaping the spacecraft's path with the mathematics of celestial mechanics. This is one of the elegant truths of spaceflight. A spacecraft can steal speed without engines in the ordinary sense, not by violating conservation of energy, but by falling through the moving gravitational field of a planet and leaving with a changed trajectory, while the planet itself loses or gains an immeasurably tiny amount of orbital momentum. Cassini's journey to Saturn was therefore not a simple voyage through emptiness. It was a long negotiation with gravity, a patient sequence of curves planned years in advance, proof that reaching the outer planets requires not only power, but timing, geometry, and trust in equations. When Cassini finally entered orbit around Saturn in 2004, it did something no telescope could do. It stayed. That word matters. Flybys are glimpses, but orbit is residence. Cassini watched Saturn through changing seasons, crossed ring planes, listened to radio emissions, mapped magnetospheric particles, measured the gravity field, studied atmospheric storms, observed the hexagon, traced shadows across the rings, and returned images in which the planet stopped being an icon and became a place of active physics. It showed that Saturn's rings were not decorative bands, but a disk of structure, waves, gaps, moonlets, spokes, edges, and fine patterns shaped by resonance and collision. It revealed the Saturn system as a crowded, interacting environment where moons sculpt rings, rings feed dust, plasma moves through magnetic fields, and tiny icy particles can carry clues from hidden oceans. Cassini also delivered Huygens to Titan, and in 2005 that probe descended through Titan's thick orange atmosphere, giving humanity its first landing in the outer solar system. Huygens did what no eye on Earth could have done. It fell through haze, recorded winds, photographed branching channels, and came to rest on a frozen landscape shaped by methane and ethane rather than liquid water. That descent changed Titan from a mysterious orange ball into a world with weather, drainage, shorelines, dunes, and chemistry rich enough to make astrobiology feel both thrilling and uneasy. But if Titan gave Cassini a dreamlike surface, Enceladus gave it a deeper shock. Cassini discovered that this small bright moon near Saturn was spraying plumes from fractures near its south pole. And when the spacecraft flew through those plumes, its instruments detected water vapor, ice grains, salts, organic compounds, and later evidence connected to molecular hydrogen, pointing toward a subsurface salty ocean interacting with rock. A moon that once seemed minor became one of the most important places in the search for habitable environments beyond Earth. This is why Cassini's final death was chosen with such care. By the end of the mission, the spacecraft could no longer be allowed to wander indefinitely through the Saturn system, because if it eventually crashed into Titan or Enceladus, even the remote possibility of contaminating a world of astrobiological interest with Earth microbes had to be avoided. So Cassini was given an ending that protected the moons it had made precious. It would not be left to chance. It would enter Saturn itself, a planet believed to be far too hostile for life as we know it, and disappear in a place where contamination was not a concern. The grand finale, as NASA called the last phase, was also scientifically bold. Cassini made a series of daring dives between Saturn and its innermost rings, a region that had never been explored so closely, threading a narrow gap between the planet's cloud tops and the ring system. This was not only symbolic. Those orbits allowed measurements of Saturn's gravity and magnetic field with unusual precision, helping scientists estimate the mass of the rings, probe the depth of the winds, study ring material falling into the atmosphere, and examine the planet's internal structure in ways that could not be done from safer, wider paths. In these final months, Cassini became like a lantern lowered between two dangers: Saturn below, rings above, both beautiful, both capable of destroying it if the geometry failed. The spacecraft's motion was governed by orbital mechanics, but its survival depended on navigation so accurate that tiny errors mattered across enormous distances. Every signal from Earth took more than an hour to arrive, and every signal from Cassini took more than an hour to return, so there was no real-time steering in the human sense. The mission team could not hold the spacecraft's hand. They could only send commands, wait, listen, correct, and trust the machine. That delay gives the story a lonely quality. Cassini was never conscious, but it was alone in the most practical meaning of the word, carrying instructions through a place where help could not arrive quickly, and where every measurement had to cross the dark before anyone knew it had succeeded. On September 15, 2017, Cassini entered Saturn's atmosphere. It kept its antenna pointed toward Earth for as long as it could, transmitting data in real time because there would be no recorder to recover, no wreckage to visit, no black box waiting on a surface. The spacecraft was moving at tremendous speed relative to Saturn's cloud tops, and as atmospheric drag increased, its thrusters tried to keep the antenna aligned. For a short time, the machine fought the planet with the last precision it had, not fighting to escape because escape was no longer possible, but fighting to speak. The instruments sampled the upper atmosphere as the spacecraft descended, sending back information about composition and conditions until the atmosphere became too much. Drag overwhelmed attitude control. The antenna lost its aim. The signal vanished, and Cassini became part of Saturn. There was no visible impact crater, no final photograph from the ground, no clean ending that human imagination prefers. The spacecraft was heated, broken apart, and consumed by the atmosphere of a planet without a floor. That ending mirrors Saturn's deepest fear. A rocky world might leave wreckage. Saturn leaves disappearance. It does not give even a heroic machine a place to rest. And yet Cassini's destruction was not a defeat. It was a final measurement, a final act of protection, and a final lesson in how science behaves when wonder and responsibility meet. The mission transformed Saturn from a distant beauty into a complex system. A fluid giant with storms and seasons, rings that behave like a celestial mechanics laboratory, a magnetosphere fed by icy moons, Titan with methane weather, Enceladus with a hidden ocean, and polar structures strange enough to remind us that natural order can look almost artificial. Cassini also revealed the limits of knowing. After thousands of orbits and countless images, Saturn remained partly hidden. Its deep interior was still inferred rather than seen. Its exact rotation was still subtle. Its ring origin and age remained debated. Its moons became more mysterious, not less. This is what makes Cassini's chapter so powerful in the larger question of why Saturn is the scariest planet. Cassini brought us closer than any human generation had ever been. And closeness did not make Saturn comfortable. It made Saturn more real. It proved that the beautiful planet is not a painting, but a functioning physical kingdom, and that even our most advanced messenger could only study it for a while before being swallowed by the very environment it had revealed. In the quietest sense, Cassini was the human eye that dared to approach the ringed world, and Saturn was the answer waiting at the end of the path. Magnificent, measurable, patient, and utterly impossible to survive. The signal stopped, but the data remained, crossing into papers, models, archives, and future missions, while Cassini itself became a trace of Earth dissolved into the golden atmosphere. And somewhere, beyond the reach of that last radio whisper, Saturn continued turning, not cruel, not changed, not even aware of the small machine that had fallen into it, wearing its rings in silence as if nothing had happened at all. So after all the rings, storms, moons, shadows, fields, and falling machines, the question returns in its quietest and most serious form. Why does Saturn feel like the scariest planet? Not just the most beautiful, not just the strangest, but the one that leaves the deepest unease behind when the telescope is put away and the room becomes dark again. The answer is not that Saturn wins every contest of danger in the solar system. Venus is more immediately lethal at the surface, with crushing pressure and furnace heat. Jupiter is more massive, more violent in its radiation belts, and more dominant in gravity. Neptune has winds that can race through blue darkness at astonishing speeds. Uranus turns on its side like a tilted mystery. Mercury is scorched and airless. Mars is dry, cold, and exposed. But Saturn's sphere is different because it gathers many kinds of cosmic discomfort into one silent image. It is the planet that looks most inviting from a distance, while being almost completely impossible to approach in any human sense. It gives the mind a shape it wants to trust, a pale globe encircled by luminous rings, and then, layer by layer, removes every promise that shape seems to make. The first promise it removes is ground. A human being is an animal of surfaces. Our nervous system, our balance, our architecture, our idea of safety, and even our language of existence depend on the expectation that down eventually stops. Saturn denies that expectation more completely than any rocky nightmare could. Its visible face is not a landing place, but a pressure level in a deep hydrogen-helium atmosphere, a coordinate chosen by scientists because instruments need reference points, not because nature has provided a floor. Beneath the clouds, descent becomes a transformation through density, temperature, opacity, and pressure, until the familiar distinction between sky and planet dissolves into fluid interior physics. In that sense, Saturn is scary because it does not attack the body first. It attacks the assumptions that make a world feel like a world. The second promise it removes is stillness. From Earth, Saturn seems calm, but that calm is only motion seen from too far away. Its atmosphere is wrapped in zonal winds, shaped by rapid rotation, internal heat, condensation, convection, and planetary scale wave dynamics. The bands that appear soft and painted are rivers of gas flowing around a world without continents, without mountain ranges, without solid friction to interrupt them in the familiar way. Storms can rise from depths we cannot see, spread across latitude bands, and disturb the atmosphere on scales larger than countries. The northern hexagon adds a colder, more intellectual fear, the realization that chaos is not the only form of terror. Saturn can make order. It can place a six-sided wave around its pole, a geometric pattern of wind that looks almost deliberate while being produced by fluid dynamics, rotation, jet stream instability, and time. This is where Saturn becomes disturbing in a uniquely scientific way, because the explanation does not make the feature less eerie, it makes it more profound. The universe does not need intention to create shapes that seem intentional. It only needs equations operating under extreme conditions. The third promise Saturn removes is solidity in beauty. Its rings, the very thing that makes it beloved, are not a single graceful object, but an immense disk of orbiting ice and dust. A bright system of fragments moving around the planet according to gravity, collisions, resonances, and tidal forces. What looks like a halo may be, in part, the consequence of breakage. An icy moon disrupted, debris prevented from reassembling by Saturn's tidal field, particles sorted into a thin plane where Keplerian motion, moon resonances, and constant small impacts create structure. The rings are beautiful, but not gentle. They are delicate at a distance and dangerous up close. They show that the universe can turn ruin into symmetry, that shattered matter can become an ornament, and that a thing may be breathtaking precisely because destructive forces have been given enough time to organize it. The fourth promise Saturn removes is emptiness. Even the space around it is not empty in the human sense. Its magnetic field reaches outward into a magnetosphere filled with plasma, charged particles, radiation belts, invisible currents, auroras, and material supplied by moons like Enceladus. A spacecraft approaching Saturn could enter the planet's invisible domain before reaching anything visible, moving into a region where magnetic fields bend charged particles, where the solar wind presses against a planetary bubble, and where a small icy moon can feed the electromagnetic environment by spraying water vapor into space. This means Saturn's influence extends beyond its clouds and rings, into the darkness between its moons. The planet owns a kind of invisible geography. It has weather made of fields. It has boundaries without walls. It has hazards without color. To human perception, that is deeply unsettling, because we are able to fear what we can see, while Saturn reminds us that much of the universe's power is transparent until instruments and mathematics make it real. The fifth promise it removes is simplicity. Saturn is not merely dead and hostile. Around it move Titan and Enceladus, two moons that make the system more ambiguous than a simple wasteland. Titan has a thick atmosphere, methane and ethane lakes, hydrocarbon weather, organic haze, and possibly a hidden ocean beneath its ice. Enceladus has plumes that carry material from a subsurface ocean into space, including water, salts, organic compounds, and chemical clues that make it one of the most compelling astrobiological targets known. Neither moon proves life, and careful science must not pretend otherwise. But both moons expand the map of possible habitability. They make Saturn frightening, not because they confirm biology in darkness, but because they make the question reasonable. A system centered on a planet no human could survive may still contain environments where liquid water, chemistry, rock interaction, and energy exist together. That contradiction is more haunting than emptiness. It suggests that the universe may not divide itself neatly into living places and dead places, safe places and hostile places, familiar places and impossible ones. Saturn's realm is a cold kingdom where unlivable grandeur and possible habitability coexist, and the mind has to hold both truths at once. Cassini made all of this real. Before Cassini, Saturn could remain a distant symbol. But the spacecraft stayed there, orbited, measured, watched seasons change, sent Huygens into Titan's haze, flew through Enceladus's plumes, studied rings, storms, gravity, magnetism, and moons, then finally entered Saturn's atmosphere and vanished. Its ending is the perfect scientific mirror of Saturn's fear. Even our most capable messenger could not land, could not rest, could not leave a monument on a surface. It descended into the atmosphere, transmitted for as long as it could, lost orientation under drag, and became part of the planet's clouds. The signal stopped, and Saturn continued turning. There is no cruelty in that, and that absence of cruelty is part of the terror. Saturn is not hostile in the emotional sense. It is indifferent in the physical sense. It obeys gravity, thermodynamics, electromagnetism, orbital mechanics, and fluid dynamics with flawless calm. And none of those laws contain a clause for human comfort. This is why Saturn can fairly be called the scariest planet in a poetic and scientific sense. Not because it is the single most lethal object by every measurement, but because it most perfectly combines beauty, scale, depth, invisibility, ambiguity, and indifference. It is beautiful enough to attract the eye, vast enough to humble the mind, fluid enough to deny ground, stormy enough to hide violence beneath softness, geometric enough to seem unnatural, ringed enough to turn destruction into elegance, magnetic enough to make emptiness dangerous, and surrounded by moons mysterious enough to disturb our definition of where life might belong. It is a planet that makes fear slow. Not panic, not shock, not the bright fear of an explosion, but the quiet fear that comes when understanding deepens and every new fact makes the world less human. And perhaps that is the final reason Saturn stays with us. It does not simply show us that space is dangerous. We already know that. It shows us that danger can be magnificent, that truth can be gentle in appearance and merciless in structure, and that the universe is under no obligation to make its most beautiful places survivable. When you look at Saturn in the night sky, you are seeing sunlight weakened by distance, reflected from clouds that have no ground beneath them, framed by rings made of ice in endless fall, surrounded by moons that may hold oceans under frozen shells, and enclosed within invisible fields that reach into black space. You are seeing a world that can be studied, measured, modeled, and admired, but not entered as a home. That is the real disturbance. Saturn is not scary because it looks like a monster. Saturn is scary because it looks like peace, and then teaches us, with perfect silence, that peace and safety are not the same thing. And now, as Saturn keeps turning quietly in the dark, we're reminded that the universe can be beautiful, peaceful, and deeply unsettling all at once. Thank you for